The second term of a geometric progression is 6 and its fifth term is 9 times its third term. Find the geometric progression. Alright. Again, we're dealing with the terms and the value of the term. So if you guys remember, the formula for the nth term of a geometric progression is a into r raised to n minus 1. We'll be using this formula in this sum, right? So they've given us the value of the second term. Second term can be considered as t2, right? Second term. That is given to us as 6, right? So t2 is equal to 6, and t2, the second term in terms of a and r, can be written as a into r, right? ar raised to n minus 1. So ar raised to 2 minus 1 will make it 2 minus 1 will make it 1. So I get a into r is equal to 6, right? So let this be our first equation. They've given us another condition. If you guys read it carefully, it tells us that the fifth term is 9 times the third term. So let's write down that condition as well. So the fifth term is t5, and that is 9 times the third term. So 9 times is 9 into third term is t3, right? Now let's express all of these. Let's express t5 and t3 also in terms of a and r, like we've done before in the previous equation. So t5 becomes ar raised to 5 minus 1, which is ar raised to 4, is equal to 9 times, so 9 into t3 becomes ar square, right? 3 minus 1, correct? So let's simplify this a little further. If you notice, I can take the, let's keep the number here and let's take this entire term to the other side of the equation. So it's multiplication here, become division on the other side. I get ar raised to 4 divided by ar square equal to 9. Now the a in the numerator and denominator get cancelled, so I'm left with r raised to 4 upon r square, which is r square is equal to 9. Okay, so r square is equal to 9. So that means r would be equal to the square root of 9. Let's extend this a little more. So r would be equal to the square root of 9. So which would mean that r is equal to 3 or r is equal to negative 3. Right? R could take both the values. Both the values for are possible. All right. Now we have the values of r. So let's substitute those in equation number 1 to get the value of a as well. Right. So substituting values of r in equation number 1. Right. What do we get by doing that, right? So by doing this we get ar raised to 6. So when we substitute r is equal to 3, we get a into 3 is equal to 6, or, right, so because there are two conditions here, so or a into negative 3, right? Don't forget, you consider both the conditions. So a into negative 3 is equal to 6. If you solve the first equation, a into 3 is equal to 6, I get the value of a as 2, right? And if I solve the second one, I get the value of a as negative 2. Alright, so I have the value of a and have the value of r. The question was to find the geometric progression, right? To find the required geometric progression. So if I have the first term and the common ratio, I can easily find the geometric progression. So the first term is a, the term after that is a into r, right? The first term into the common ratio. So a into r over here would be 2 into the common ratio 3, which is 6. Or in the second case, a into r would be negative 2 into negative 3, which is also 6, right? The third term, which would be ar square, would be 6, which we know, which would the next term, which is ar square, which would be 2 into 3 square. So 9 and 2, which is 18, or ar square for the second case would be negative 2 into negative 3 square, which would give me negative 18 actually, right? Let's also find the fourth term and then we can write our GP out. So then next term would be ar raised to 4, which is 2 into 3 raised to 3, 2 into 3 raised to, my bad, the fourth term would be ar cube, so which is 3 into 3, right? So that will be 54, or in this case AR cube would be -2 into -3 cube, which will give me 54 again, right? So I have found the geometric progressions. That's two situations because the value of r could either be +3 or -3, right? So let's write down our final answer. Therefore, the required geometric progression is either 2, 6, 18, 54, and so on, or -2, 6, -18, 54, and so on. So both of these arithmetic progressions satisfy the given condition, right? And this is our final answer.